Hmm. Hello.
Hello, sir.
Yeah, can you hear me?
Yes, I can hear you.
Hmm. So let the other people come because they were saying that they will join around 11 o'clock.
Yes, we have a class right now.
Yeah, so we can start at 11. So meanwhile, if you have any question, you can just discuss with me and thing like that. By the way, how was the exam? You are attending both classes, right? Basic mathematics and fundamental
Yeah.
mathematics, right? Yeah.
Only basic mathematics, not fundamental, I think.
Hmm. But I saw your name in both courses, no?
Um, last year's I'm in fundamental maths only.
Hmm. Okay. So
This.
okay, that is fine. Can you see my screen now? I share whiteboard.
Yes, I can see it.
Okay, that's cool. Okay. So if you have any question, you can just go ahead. Then we can also discuss with other students as well.
So the class will start in at 11 o'clock, right? Because I have a class too.
Okay.
I'm on 2 Zoom calls.
Yeah, you can just go ahead with that class. We can regularly like we can start at 11 regular class. No problem.
Okay.
Mhm.
Well, then I'll rejoin later.
Yeah, sure,
Okay,
no
sir.
problem. Mhm.
Okay, thank
Bye.
you.
Welcome.
See you soon.
I think now it is recording.
Yes, now it is.
Yeah.
Okay. Okay. So this is the standard maximization form when you have a profit function and you would be given some constraints. Constraint means you would be given some linear equations in inequality form, and all the inequalities would be in less than equal form. Like here you can see all the constraints are in less than equal form. Then we will say that this is the standard maximization problem. Is that clear? Right? You can I think it would be better if you unmute your microphone and you can give your responses at the same time. Then it will give me more feel like I'm delivering a regular lecture. Can you hear me now?
Yes.
Yeah.
Can you
Okay.
put
Yeah,
on full
you can
screen?
just unmute your microphone and just ask me questions at the spot. Then it will give me a more feelings like that. Yes, I am delivering a regular lecture. Okay.
Okay.
So, so here now you can see on the next slide, we are given a function like a general function z equals to 5x plus 10y, and you can see all the constraints. We are given two constraints and both constraints are in less than form. When all the constraints are in less than form and we are given a function and we are asked to maximize it, it means that this is a standard simplex method. What are those two conditions for to apply simplex method is you should be given an objective function and all the constraints should be in less than equal form. Okay, fine. Then here you can see normally what we do, we write those equations in an equation form and we solve them simultaneously. But here in simplex method, we don't need to solve them simultaneously. Uh, if you draw like this is an example from chapter 5. If you have done your assignment in chapter 5, what we used to do, we used to plot these two equations like 8x plus 8y less than equals to 160, 4x plus 12y less than equals to 180. We plot these two equations and we see the feasible region where two lines intersect. That is our feasible region. X greater than 0. If I can open a Word file here as well, then I think it would be more convenient so that I can write at the same time. How to move this? Can you see this Word file?
Yeah.
Yes.
Okay. So normally what we used to do, for example, you are given z equals to 5x plus 10y. This is our objective function. Now we have inequalities 8x plus 8y less than equals to 160 and 4x plus 12y less than equals to 180. We write these two equations in an equation form 8x 8y equals to 160. We plot this equation and this is the graph of this first equation. How to plot this equation, like from college algebra and also from linear equations, you know how to plot these two equations. You can choose any value for x. If I say x equals to 0, if I plot x equals to 0, I can get y. Y would be 20. Similarly, you can say y equals to 0, you can get x equals to 20. You can plot these 2 points on a graph paper and you can draw the graph for this first equation. Similarly, for this second equation, we write it in an equation form 4x plus 12y equals to 180. We plot this equation, and after plotting this equation, then we draw these two constants x greater than equals to 0 and y greater than equals to 0. What does it mean? It means that if you are dealing with some real life commodities, real data, that data cannot be negative like this. So in that case, if x is greater than 0, if we say x is greater than 0, it means that we have this line. And if we say y greater than 0, in that case, we mean that we have this line. So it means that our graph will be in this area. Then we draw the second line, which is 8x plus 8y less than equals to 160. And the second line is like this. So the enclosed area, if you can focus on it, the enclosed area is this one. This one is the enclosed area. So all the points which are on the intersection of lines, for example, this point, let me change the color. This point, this point, and this point, and this point. These are our corner points. We substitute these corner points into our objective function, which is z equals to 5x plus 10y. And wherever we find the maximum value, we say that that is our solution. So that is all what we did in chapter 5. But in chapter 6, we don't need to do all this. In chapter 6, we will apply a simplex method, which is called standard maximization problem. Like here. Now you can see that we want to maximize that function. If we want to maximize that function, we will try to add some slacks. Slacks means to say that, here you can see that, how to move on the next page. Okay, so here you can see that now we are trying to apply the simplex method. We are given uh, we are given 8x plus 8y less than equals to 160. So this side is less than this side, right? So let's say 4 is less than 5. I know I need to add something on the left side, then these two things will be equal. What should I write? What should I need to add on the left side? Can you tell me?
1.
One.
Yes, but it is a simple case. We know that we need to add 1, but let's say we don't know what we need to add. But one thing is for sure, we know we need to add on the left side, then it will be equal. If I add something on the right side, it will not become equal, it will be remain in inequality. Understand? Similarly, here we know that in this function, we know that we need to add something on the left side. 8x plus 8y plus we say that slack variable s1, now it is equals to 160. Similarly, for the second equation, 4x plus 12y, I know that I need to add something on the left side, then they will be equal. These s1 and s2, these are called slack variables. That is what we need to know, that what is s1 and what is s2. Like here in this simple example, we know that a is 1. But in that case, we don't know what is s1 and what is s2. These are called slack variables and we need to find them. Okay, so here you can see that they are called slack variables because they take up the slack between the left and right hand side of the inequality. Note that slack variable must be non-negative. This is very important statement. Slack variable must be non-negative. We will use this line later on, so you must not forget it. Okay, so
Or what if we get an equation that's not less than or equal to, but more than or equal to? Do we first have to convert it to the sign facing, the other way?
yes, that is the second lecture. First of all, for example, if it is greater than, you need to convert it first into the less than, then you can apply the simplex method. For example, if I understood what you are saying, that let's say the constant is 8x plus 8y greater than 160. That is what you mean?
Yes.
So first we need to convert it into the less than form. How we can do this? We can multiply both sides with negative sign. It will become minus 8x minus 8y less than minus 160. First we need to change its sign into the less than form. Then we can apply the simplex method. That is the section related to 6.3. That was our latest lecture. If you, I think you have seen it there. Okay, so here we know that we have two equations in 4 unknowns, x, y, s1 and s2. The system has an infinite number of solutions. since there are more unknowns than equation. We can make a system have a unique solution by assigning two of the variables a value of 0 and then solve for the remaining two variables. This is called a basic solution. Now, there are very important two terminologies. One is called basic variable, the other one is called non-basic variables. We always assign value 0 to our non-basic variables. This is very important statement. Don't forget it. We always assign value 0 to our non-basic variables. We will use this concept later on when we will solve the problems related to simplex method. Understand? Right? Okay. I need to open lecture 6.2 now. So here you can see that the simplex method maximization with problem constraints less than equal. You can see that here it is less than equal. Okay. So the student will able to set up the initial system, which is called the simplex tableau, and also you will able to find the pivot operation on the simplex tableau and also interpret the simplex process geometrically. So here we are discussing this problem p equals to 5x plus 10y, 8x plus 8y. We have an objective function and all the constraints are in less than equal form. It means that we can apply simplex method. Can you hear me?
Well, it's on
Hello?
full screen now.
Hello?
It just froze.
Yes.
Hello?
Hello.
Can you hear me?
No,
Yes.
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 Okay.
Yes. Good.
Can you see my screen as well, computer screen?
No,
No,
No.
I can't.
you should stop recording and then doesn't it work like that, right? If
Uh,
you stop recording and then you can
can you see now?
share.
Okay, it says it started. Wait.
it's
No.
starting now.
Yes.
Now
Yes.
we can.
Can you see
Yes.
now? Okay. Okay.
Yeah.
Because interruption in the internet connection, I think that is why. We were on example 1, right?
Yes.
Okay. So here you can see that this is the standard maximization problem where we have a profit function and all the constraints are in less than equal form. So what we do, we add the slack variables S1 and S2 and now they are in equal form. And the most important thing is here you can see that P equals to 5x plus 10y. Mathematically, I can write it. We can move this p to the other side. It can be 5x plus 10y minus p, but in simplex method, this is a big mistake. Don't write it like that. Always bring variables to the left side and change their signs. Like it was 5x on the other side, when we move it to the left side, it become minus 5x. We will move 10y to the other side, it will become minus 10y, and p is still there. So the final form will be 8x plus 8y plus s1 equals to 160, 4x plus 12y plus s2 equals to 180, and then minus 5x minus 10y plus p. Is that clear? Right?
Yes, just a
Yeah.
second. I need to write it down.
Okay. So now we write it in a matrix form. You see, we had these variables x1, x2, s1, s2, and p. We write our equations in a matrix form, like here you can see on the side 8, here we have 8, 8, and here we have 8. Then s1, the coefficient of s1 is 1, here we have s1. Then there is no s2 in the first equation, so for s2 we have 0. In the first equation there is no p, so we have 0 for the p. Equals to 160, so we have 160. Likewise in the second equation we have 4 for the x, so we have 4 here. We have 12 for the y, so we have 12 here. Y means so-called x2. Here in second equation, there is no s1, so we have 0 for s1. In second equation for s2, we have 1. There is no p in the second equation, so we have 0 equals to 180. Likewise, the third equation for x we have -5, for 10 we have -10, and sorry, for y or so-called s2 we have -10. There is no s1 and s2 in the third equation, so 0 for them, and there is p, so for p we have 1 equals to 0. Now we decide which one is basic variable and which one is non-basic variable. In all these columns, if you look at this first column, do we have 1 and rest of the elements are 0 in this first column?
No.
No.
No. So this is not a basic variable. Okay. Second column, do we have 1 and rest of the elements are 0?
No.
No.
So x2 is also not a basic variable. In the third column, do we have 1 and rest of the elements are 0?
Yes.
Yes. So S1 is basic variable. We write our basic variables on the left side. So S1 is the first basic variable. We write it in the first row. In the fourth column, do we have 1 and rest of the elements are 0?
Yes.
Yes. So S2 is basic variable. We write it in the second row. Similarly, P is our basic variable. We write it here. On the side column, outside the matrix, we write our all basic variables. And what is the condition? How do we know which one is basic variable? In the basic variables column, we always have 1 and rest of the elements are 0. Understand? Okay. Now what we do, we see in the bottom row, the most negative number. In the bottom row, which one is the most negative number?
-10.
-10.
-10. So this second column is our pivot column. Understand? This second column is our pivot column. And now we will divide the extreme right column, which is 160, 180, and 0. We will divide these numbers with the pivotal column, like 160 divided by 8, 180 divided by 12. Understand? And we see what we get. You see, we divide 160 with 8, we divide 180 with 12, we get 20 and 15. Which one is the smallest number, 20 or 15?
15.
15.
So 15 is the smaller number than 20. So this second row is our pivot row. Now the second column is pivot column, the second row is pivot row. So this 12 is our pivot element. Understand? This 12 is our pivot element. And one more thing which is very important, this x2, this second column was pivot column. So this x2 will move into the basic variables, and where it will move into the pivot rows position. Pivot row was second one, so this x2 will move into the second row's position. Is that clear?
No.
Yes.
This point
No,
is
not to me. Hold on.
okay. See,
We select this row because it's 15 is the least
yes,
is the least number, right?
yes.
Okay.
And
And
yeah.
then we get 12
Mhm.
because you know that lines up with the column and the row.
Yeah.
And then what do we do?
Now, after deciding pivot element, we will shift elements. We will shift variables. How do we shift the variables? First of all, which variable we will shift? We will shift the variable which is corresponding to the pivot column. This is our pivot column. The second one is our pivot column. And corresponding to second column, which variable we have? We have x2. Okay, we will shift x2 So in which position we will shift x2? We will shift x2 in the position of pivot row. Which
Okay.
one is our pivot row? This second row is our pivot row. So this x2 will move into this position, into S2's position. Understand?
Yes, and then what happens?
Is that clear?
Yeah. I just don't see what happens next.
Okay. Now we will convert this pivot element, which is 12, into 1. How do we convert it? We can simply divide this 12, this whole second row by 12. If we divide, you can see this 12 is in red color because that is our pivot element. We divide this second row by 12, we get 1 here. You can see in the second matrix, this 4 by 12 is 1 by 3, 12 divided by 12 is 1, 0 divided by 12 is 0, 1 divided by 12 is 1 by 12, 0 divided by 12 is 0, 180 divided by 12 is 15. Now with the help of this one, we will make 0 above and below. Understand? And you know how to apply row operations. We will multiply this second row with -8. We will add it into the first row. We will get 0 here. Similarly, we will multiply this second row with -10 and we will add the result into the third row. Sorry, we will multiply with the 10 because here we have -10. So we will multiply the second row by 10. We will add the result into the third row. So we will get zeros above and below this pivot element, which is 1. So here when we do these operations, after doing these operations, as I said, this x2 will move into this position. You can see that now here we have x2 instead of s2, and we have now here 1. With the help of this one, we had 0 here and 0 here. Is that clear?
Wait. I just need to write this down.
Mm-hmm.
This one.
Can you send the PPT after?
I have already, this is the PPT which I uploaded in the system, in the BB, and also in the
Yeah,
YouTube.
in
Yeah,
the
it's on BB.
yeah, I know. In the okay.
Yeah, this video, this PPT is with my recording. I have
Yes.
explained all these things in the recording as well.
Yes.
So you can stop me wherever you are confused. I can explain it again, no problem.
Okay, so for like the element, the first element in the first column, how did you get it to be 16 over 3? What did you divide by what?
See, we multiply this second row with -8. Okay. Multiply this second row with -8. Let me do it for you. Mm. You see, we have 8, 8, 1,
Mhm.
0, 0, and 160. We have 1 by 3, 1, 0, 1 by 12, 0, 15,
Mhm.
-5, -10, 0, 0, 1, and 0. Now with the help of this one, I want to make 0 here and 0 here. So for this, what I need to bring change in row 1. How I will bring change in row 1? I multiply row 2 with -8 and I add the result in row 1. Let me perform this operation first. So if I multiply row 2 by 8, it will become -8 by 3, this number, right? And I will add it into the first row. So 8 minus 8 by 3. So if you subtract them, 24 minus 8 by 3, which is 16 by 3. So here I will get 16 by 3. Understand? And
Yeah.
minus 8 plus 8, it will become 0. I will multiply this 0 with minus 8, add the result into 1, it will become, it will remain 1. It will remain 1. Now I multiply this 1 by 12 with minus 8, it will become minus 12 by 8. I will add it into the 0, it will become minus 8 by 12. I multiply minus 8 with 0, it will be remain 0. Now 15 times 8. What is 15 times 8? It is, I think, 120. So minus 120 plus 160, it is 40. So this row is still there, 1, 0, 1 by 12, 0, and 15. Now, with the help of this one, I make 0 here. To make 0 here, I need to bring change in row 3. So I need to multiply row 2 with positive 10 and I add the result in row 3. It will give me a new row 3. So I multiply this with 10. It will become 10 by 3 minus 5. 10 by 3 minus 5. So 10 minus 15. So it is minus 5 by 3. So here I will have minus 5 by 3. Then I multiply row 2 with 10 here and here it is minus 10. So it will become 0. 10 times 0, 0. So 0. 10 times 1 by 12 is 10 by 12 plus 0. So it will become 10 by 12. Similarly, here we will have 1. This is 150. So 150 plus 0 is 150. So you can see that now here, if you compare these two matrices, 16 by 3, 16 by 3, minus 2 by 3, if you simplify this, it will become 4, 2 and 4, 3 minus 2 by 3. Understand, Misha?
Okay. Yes. So you're trying to get the pivot column numbers first, right?
I'm applying row operations with the help of this one to make zeros above.
Right. Right.
So here you can see this is how we get this matrix now. Understand?
Mhm. Yes. Yes.
Everybody is here listening?
Yes.
Okay.
Yes.
Now, again, we will start, this is called simplex procedure. Again, we will start the simplex procedure. If you see in the bottom row here, which one is the most negative number in the bottom row?
Negative 5 over 3.
The only number is negative, which is negative 5 by 3. So this is our now pivot column. Understand? This is our pivot column. And here, now we will decide the pivot row. We will divide this 40 with 16 by 3. When we divide this 40 with 16 by 3, we get 7.5. You can see here in the PPT. Then we divide this 15. We divide this 15 with 1 by 3 and we see what do we get? We get 45. So which one is the smallest quotient, 7.5 or 45?
7.5.
7.5. So this is pivot row. This is our pivot row. And this is our pivotal element. 16 by 3 is our pivot element. So now you can see that which variable will move into the basic variables position. You can see here pivot column. The pivot column is the first column and the variable above first column is x1. Now x1 will move. X1 will move where? X1 will move into the pivot rows position. This first row is pivot row. So x1 will move into the position of S1. So first of all, we will convert this 16 by 3 into 1 like we did before for this one. And with the help of this one, we will make 0 below this one where we have 1 by 3 and minus 5 by 3 like we did before by applying row operations. Okay. So here now, You can see we divide 40 with 16 by 3, we have 7.5. We divide 15 with 1 by 3, we have 45. 7.5 is the smallest quotient, so the first row is pivot row. X1 will move here in the position of S1. Now we will divide this 16 by 3 with 1, or 16 by 3. The first row will be divided by 16 by 3, we will get 1 here. Now we apply row operations to make 0 here and 0 here, like you did in the Gauss-Jordan elimination method, or like I did here. You can see in the Word file here, exactly like this. We will apply the row operations and we will make zeros below this one, 0 and 0. So again, you will draw a line in the bottom row and you will see which one is the negative number. Can you see any negative number in the bottom row?
No.
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 It means we will stop here. If there would be any negative number, for example, I am saying, let's say this is minus 5 by 16. It means that we will continue our simplex procedure. So in that case, it would be the third column would be the pivot column. And then we will decide which one is the pivot row, like by dividing the extreme rightmost column with the respective pivotal columns numbers. And we will see the smallest quotient like we did 2 times before. But now in the bottom row, we don't have any negative number. It means that we are done with the simplex method. So we can write it back into the equation form. Like you can see how to read the solution. It is also very interesting. Like you can see, if I write them back into the equation form, if I write them back into the equation form, you can see it would be x1 plus 0x2 plus 3 by 16, that is S1, minus 1 by 8 S2 plus 0p equals to 7.5, right? If I write this matrix back into the equation form, it would be like this. Is that clear? Is that clear?
Wait. Yes.
Right. Now I write this second equation in the second row into the equation form. 0x1 plus x2 minus 1 by 16 s1 plus 1 by 8 s2 plus 0p equals to 12.5. Likewise, the third row would be 0x1 0x2 5 by 16 s1 plus 5 by 8 s2 plus p equals to 162.5. Everybody is there? Can you hear and can you listen?
Yes.
Yes.
Yeah.
Okay. So here in this matrix, if you look at this final matrix, can you tell me which one is basic variable and which one is non-basic variable?
So x1 would be basic.
Very good. Because in x1, in the x1's column, we have 1 and rest of the elements are 0. So x1 is basic variable. In the x2's column, again, we have 1 and rest of the elements are 0. But in S1's column, we don't have 1 and rest of the elements are also not 0. In S2's column, we don't have 1 and rest of the elements are also not 0. And similarly in P, we have 1 and rest of the elements are 0. So P, x1 and x2 are basic variables. x1, x2 and p are basic variables. and S1 and S2 are known basic variables. Understand? And
Yes.
I I read one
Yes.
statement, I read one statement in the beginning of the PPT. That was, I said we will use this statement later on. We always assign value 0 to our non-basic variables. S1 and S2 are non-basic variables. So S1 will be 0, S2 will be 0. If S1 is 0, so this term will go out. S2 is 0, this term will go out. This is 0x2, it is nothing. This is 0p, it is nothing. So x1 equals to 7.5. Similarly, this is 0x1, it is nothing. We assign value 0 to non-basic variable. S1 is 0, S2 is 0, P is also 0. So x2 equals to 12.5. Likewise, this is nothing, this is nothing. S1 is 0, S2 is 0, and P is 162.5. So this is how, you don't need to do all this. This is just for your explanation that how do we write the solution. This part is just for your explanation. From here, you can read directly the solution, that x1 is 7.5, x2 is 12.5, and p is 162.5. And we always assign value 0 to our non-basic variables. Is that clear?
Yes.
Yeah.
So this is how we apply the simplex method. Any other question about maximization? This was about maximization. Here we can just go through from the standard procedure of simplex method. First of all, we determine the number of variables. Like you will be given simple constraints in x1, x2, x3 forms. Then we add the slack variables. Those are also our variables. Determine the number of basic variables and the number of non-basic variables. Initially, our x1, x2, x3, or number of all the x's would be our non-basic variables. These numbers do not change during the simplex process. Then selecting the basic variables. Normally, initially our slack variables are basic variable. Like initially you see S1, S2 are slack variables. A variable can be selected as a basic variable only if it corresponds to a column. This is very important. I'm reading very important statement. A variable can be selected as a basic variable only if it corresponds to a column in the tableau that has exactly one non-zero element, usually 1, and the non-zero element in the column is the same row as the non-zero element in the column of another basic variable. This procedure always selects P as a basic variable since P column never changes during the simplex process. Okay, after selecting non-basic variables, selecting non-basic variables. After the basic variables are selected, in step 2, remaining variables are selected as non-basic variables. The tableau column under the non-basic variables usually contain more than one non-zero element. We have already discussed these points in this example. Are you following?
Yes.
Yes.
Okay. So now how do we apply the process? Locate the most negative indicator in the bottom row of the tableau to the left of the P column. The negative number with the largest absolute value. The column containing this element is pivot column. Like we see in the bottom row, which one is the most negative number, that indicates our pivot column. If there is a tie, this is important statement in your assignments or in the exams, this would be important thing. If there is a tie for the most negative indicator, choose either column. Then you are free to choose either one. Means to say that if, let's say, in the bottom row you have two most negative number, let's say -10 and -10, you can choose either column in that case. After that, divide each positive. This is also very important. Divide this positive word is very important. Divide each positive element in the pivot column above the dashed line into the corresponding element in the last column. If there is any negative number, what is he saying? I give you an example. Can you hear me?
Yeah.
Okay. How many people are there in the group, by the way? I cannot see now.
I think it's about 9.
Okay. Everybody is listening?
Yes.
Okay.
Yes.
For example, here
Yes.
I write, I give you a simple example. Let's say we have -5, -5, 2, 3, 1, 0. Let's say like this. Here you have 2, 1, 3, 1, 2, 5. Now the most negative number below the in the bottom line, we have two most negative number, -5 and -5. You can choose either one as a pivot column. Either you choose this one or you choose that one. Both are fine, no problem. Okay. Now the second case is, in the second case, what is he saying? You see the number 2, divide each positive element. I give you another example. Let's say here we have -10, -2, 3, 4, 5. Here we have -1, 2, 3, 1. Here we have 2, 7, 5, 1. And this is our last column. Let's say 0, 12, 10, 15, 7, like this. Here you have some numbers. I am not writing them randomly. Normally what happens, most negative number in the bottom row indicates our pivot column. That is pivot column. To indicate the pivot row, what do? We divide the extreme right column with the corresponding pivot column. 7 divided by 1, 15 divided by 3, 10 divided by 2. But here you see 12 is corresponding to -1. Can you see? 12 is corresponding to
Minus.
-1. But we will not divide 12 with -1, because in the second part it says divide each positive element in the pivot column. In the pivot column, this is pivot column, positive elements are 2, 3 and 1. Divide only with the positive element. That is what this number 2 saying. Understand? Did you get that point?
Yes.
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 Okay. The pivot row is the row corresponding to the smallest quotient obtained. Here the smallest quotient is 3 equal 3, 5. So this would be the smallest quotient. Here in that case would be this row. If the pivot column above the dashed line, this is also a very important point. If the pivot column above the dashed line has no positive element, let's say instead of -1 we have -2, -3, again -1. There is no positive element above the pivot column. So in that case you will say there is no solution and we stop. Is that clear?
No, wait. Which dash line?
Mm-hmm.
Oh, that line. Jesus.
Okay.
Plus, okay. Wait. So what do we do for 12 -1 though? We just ignore it, or do we
Yeah, we just
turn 1 to plus?
no, we just ignore it.
Okay.
And then the step 3, the pivot element is the element in the intersection of pivot column and pivot row. Like this is pivot column, this one is pivot column, this one is pivot row, and that is the intersection. So 3 is our pivotal element. After identifying the pivotal element, what we do, a pivot operation or pivoting consisting of performing row operations as follows, like we did, multiply the pivot row by the reciprocal of the element to transform the pivot element into a one. Step 1 and step 2, in fact all the steps are exactly the same which we have performed. So here you can see that now the simplex method procedure. Step 1, write the standard maximization problem. What does it mean? It means that if you are given a profit function, P equals to X x2. I'm just giving you a simple example. Random, I'm writing random variables, understand? And you will be given some constants, x1, x2, x3 less than 0, or let's say less than 9, minus x1, x2 plus x3 less than 2. This is the standard maximization problem. You are given a profit function and all the constraints are in less than equal form. Okay. Step 2. Are there any negative indicator in the bottom row? When you will write this system into the simplex tableau here, the objective function here, this objective function will be minus x1 minus x2 minus x3 plus p equals to 0. So the bottom row will be minus 1 minus 1 minus 1 0 0 0 and 1. It says that in step 2, are there any negative indicators in the bottom row? Yes, there are negative indicators in the bottom row. If yes, select
Sir,
yes.
can you scroll down on the Word document because we cannot see it?
You
Oh, sorry. No, delete that. Sorry.
I did not get your point. What do you say?
No. Yeah.
Okay, everything is fine?
No, it's fine.
Okay,
Yes. Sorry.
okay. So in step 2, we say that are there any negative indicator in the bottom row? You can see, yes, there are negative indicators in the bottom row. Then we move to the step 3, select the pivot column. Which one is the most negative number in the bottom row? All three are same. You can choose either one. Let's say we say that this -1 is the pivot column. Step 4, are there any positive elements in the pivot column above the dashed line? Above this dashed line here, is there any positive element? If there is positive element, you will continue. If there is no positive element, then you will stop it there. Okay. If there are positive elements, then select the pivot element and perform the pivot operations. How we will select the pivot element? We will decide which one is the pivot row, either this one, either that one, either that one. If this is the pivot element, then we will perform the row operations to make it one and move and make the elements which are below this 1 equals to 0. So this is the process of simplex method. Now we perform one more example. It would be more convenient and I think it would be more understandable for you. I hope things are now much more easier than before. Isn't it? Anis, are you there?
I'm here.
Okay. Did not listen anything from you. Misha and Carolina are participating. Seems like I'm only teaching Misha and Carolina.
I think I need to redo it later because I'm not really following, but I'm listening to the explanations.
No. If you don't follow, you just ask me questions at the spot. It is just a normal regular class. The only difference we cannot see each other, but the rest of are exactly same. Don't put it aside. Just ask me questions at the spot, okay? It is same
Okay.
for everybody.
Can I ask you a question about the homework?
Let me finish this first, please.
Okay.
Then we can move to the homework as well. Okay. Okay. So this is the second example. I'm not reading this example. When you formulate this example, you will get this function which is called a profit function. P equals to 100x1 plus 300x2 plus 200x3, and you will have some constraints. What are those constraints? Like x1 plus x2 plus x3 less than 100, 40x1 plus 20x2 plus 30x3 less than 3200, x1 plus 2x2 plus x3 again less than 60. So we have a standard maximization problem. We will apply a simplex method To apply simplex method, first of all, we add the slack variables. Like here you can see we add S1, we add S2, and we add S3. Now they are equals to 100, 32, 160. After that, we write them in a matrix form. To do, before doing this, we move these 100x1, 300x2, 200x2 into the left side. Okay.
So hold on. P
Mhm.
becomes P becomes one of the factors, so it becomes x1 plus x2 plus x3 plus s1 plus p equals something.
Yes, yes, p equals to 0.
Okay.
Yeah. Now we write this system into a matrix form. When we will write it into a matrix form, you can see that here. This is a matrix form and we write all the variables on the top and we write our basic variables on the left side. S1 is basic variable, is on the left side. S2 is basic variable, it is on the left side. S3 is basic variable on the left side. Similarly, P is basic variable, it is also on the left side. Understand?
Mhm.
Yes.
Okay. So from the bottom row, which one is the most negative number? Minus 300
Negative
is the most negative
300.
number. So the second column is the pivot column. So x2 will be moving variable. Where it will move, we will see which one is the pivot row. We will divide 160 with 2, 3200 with 20, 100 with 1. So 160 divided by 2 is 80. That would be the smallest quotient. So the third row is our pivot row and x2 will move into the position of S3. Is that clear?
No.
I just don't really
Yes.
get how x2 moves into position of s3.
Mm-hmm.
I just don't really get how, I don't get how x2 moves into position of s3. I get the operations, but how does it like move there?
You see,
We just replace s3 with x2, right?
no. We will simply write S3, X2 in the position of S3 here where we have S3. But why we are writing X2 in the position of S3? Why not and in the position of S2 or why not in the position of S1? This is the important point. Because, and that's, before this, the important thing is why only we are moving X2? Why not X1? Because we are moving X2 because we are moving it because it is against pivot column. This is our,
Mhm.
the second one is the pivot column. So
Mhm.
X2 will move. Where it will move into the pivot row. The third one is the pivot row. And corresponding third row, we have S3. So X2 will move into the position of S3. We will simply write X2 here in the position of S3, nothing else. Right?
Okay.
So
Mm,
the
That was the
x3
question.
to
Mhm.
s3.
Mm-hmm.
What happens to s3? Does it just
It will just,
It becomes s2.
it will no, it will
okay.
just exit, nothing. It will not become S2 or X2. It will exit. Okay. So we have this pivot element. With the help of this one, we will make 20 0, we will make 1 0, and we will make 300 equals to 0. So with the help of this one, we will make, you can see on the right side, there are operations. When you will perform these operations, you will get this form. Now, again, in the bottom row, we will see which one is the most negative number. In the bottom row, minus 50 is the only negative number. So the third column is our pivot column. So X3 will move. Where it will move into the pivot row. So first one is our pivot row. So X3 will move into the position of S1 simply. And we will convert this 20 into 1. Sorry, this one, yeah, we will move this 0.5 This 0.5 is into 1, like here you can see. And when, yes, yes. Everything is fine. Hello.
Yeah, I
Yeah.
guess.
Okay.
Anais one. Oh, okay.
Okay. Now with the help of
Anais?
this one, we will make 0 in the position of 20. We will make 0 in the position of 0.5 and also minus 50 by applying these row operations. When we apply these row operations, we get this position and this condition. Now, is there any negative number in the bottom row?
No.
When you say the bottom row, do you mean the very last row or X2?
Exactly, the very last row.
Okay.
So in the
So
bottom row or in the very
which I just don't get like the row operations, how they're supposed to work. Which numbers are you trying to get to 1 and which numbers are you trying to get to? Oh, are you trying to get the pivot elements to equal 1?
Yes.
Is that right?
Yes, yes,
Okay.
yes, yes. So you can read the solution directly. X3 is 40, S2 is 800, X2 is 60, and P is 26,000. So we will stop the simplex process. And now I tell you the beauty of this example. Apparently, if I jump back to the equation, the problem was saying a farmer owns 100 acres of farm and plans to plant at most 3 crops. He had 3,200. He had total amount 3,200. So normally in real life we say that the more you invest, the more you earn. But this is not valid every time. And here this is a very good example that if you, apparently we can say that if we invest 3,200 we can get more return, but in this example it proves it wrong. That here you can see that slack variable S2 is 800. He will get maximum profit. Maximum profit is 26,000 by investing 2,400. By investing 2,400, and he can save 800. He don't need to invest whole 3,200. So this slack is 800. Thus, if the farmer plants 60 acres in crop B, 40 acres in crop C, and he does not need to plant crop A, the maximum profit is 26,000 will be released. The fact that S2 equals to 800 tells us that this maximum profit is reached by using only 2,400 of the 3,200 available for seeds. That is, we have a slack of 800 that can be used for some other purpose. So that was the simplex method. Now you can ask me questions. Hello.
Yeah.
No, I don't have any questions, I think. I just had questions on how to do it, but not on the final.
Carolina was asking about something, assignment.
No, I think it was Caitlin, right? But I also have a question from the second video, the second like exercise. I can send you a picture in WeChat because I cannot really explain how.
If you can
wait.
send me the picture, I can see it. I have WeChat.
Yes. Okay. I'll send it in WeChat. Wait a minute.
Okay.
I have questions about the final, like final exercises.
Final exam?
No, sorry, the midterm exercises. were the one about matrices. There was one recurring question.
You can just put it in the WeChat group, or you can. Okay.
Okay, so when you're going to do from P there, the equation, and I'm wondering why it's not negative 700 and negative 900, and then you put negative 500 and negative 1000. I wonder why it's switched, or if it's wrong, or
you know,
yes.
we can put it in this way, because now we will have regular live tutorials, so you can consider it your we can start over this chapter 6 again. That was your what we did today. That was your 6.1. And in the next live tutorial, I think we have it on Wednesday, right? When we have next live tutorial?
We don't know for fundamental. We
We
don't
don't
know.
know. No one has told us anything.
No. We have arranged it. Christine
No,
sent.
it was in basic math.
No, she already arranged it. She dropped the message in the group. It is for Tuesday and Saturday. Okay. Today is Tuesday, right?
Yes.
Okay.
Yes.
We have live tutorials on 4:30 every Tuesday, and Saturday 9:30 p.m.
Okay.
9:30 Shanghai time.
Sorry.
9:30 p.m. Shanghai time.
Yeah, I will always talk about Shanghai time, so that is understood. Whenever I mention
Yes.
any time, it would be always Shanghai time or Beijing time.
Okay.
Let me drop
Next
it.
one is Saturday, right?
Yes.
Okay. Okay.
Oh, so not
I
9 p.m.
It is. It is 9:30. Saturday 9.
so 9:30 p.m. on Saturday, right?
Yes, I will make a schedule, and you will get a message as well. Okay, let's go over through this quickly. Chapter 6, 6.2, and then lecture 7, 6.3. You're talking about this example, Carolina, right?
Sorry,
You're talking about this example, right?
I'm talking from the one you sent yesterday,
Yes,
from examples.
this one, that one. Can you see my screen?
Yes.
So this is, I just explain it again. This was the problem of minimization. Understand? To apply
Yeah.
to apply the simplex method, to apply the simplex method, the condition is to apply the simplex method. You must have an objective function, like either you have P or you have C. In this case, we have C 6x1 plus 5x2 plus 4x3 plus 8x4. and all the constraints ax1, a1, x2, blah blah blah, an, xn, all the constraints must be less than equal form. But in this case, in the minimization problem, you can see the first constraint is in less than form, the second constraint is also in less than form, but the third
And
constraint,
then you take negative. Yes.
the third constraint is in the,
For 700 and 900.
no, look at the third constraint. Third constraint is in the greater than equal form. Fourth constraint is also in greater than equal form. First, now listen it very carefully. When you have, this is called mixed constraints. When you have mixed constraints, some are less than, some are greater than, then what we do, we first convert all the constraints in the greater than form. To do so, you can see in the first constraint, if I multiply with the negative sign, this less than will become greater than. You can see in the next PPT. Now I multiplied the first constraint with negative, so less than is changed into the greater one. Similarly, I multiply the second constraint with negative, so less than constraint is converted into the greater than. Now all the constraints are in greater than form. Is that clear?
Yes.
Now after converting all the constraints in greater than form, we write it in a matrix form and we take its transpose. Okay. So we write them in a matrix form and we take its transpose.
When you take transpose,
Mhm.
when you take a transpose, does the cost becomes the profit, right?
Yes, exactly. Exactly.
Mhm.
So, and we interchange rows into columns. This first row will become first column, second row will become second column, third row will become third column. Likewise, last row will become last column. And we write them back into the equation form. When we write them back into the equation form, before every constraint was here, you can see that every constraint was in greater than equal form. But after taking the transpose, when we write them back into the equation form, all the inequalities will become in less than equal form. And that is what we were discussing. To apply the simplex method, you must have an objective function. You must have an objective function, like here we have an objective function, and all the constraints must be in less than form. Here now all the constraints are in less than form. Now we can apply the simplex method. We will add the slack variables, and one more change in minimization, the slack variables will be x1, not s1. The slack variables will be x1. We will not write s1. So in the first equation, the slack variable is x1, second, x2, x3, and x4. And this is our now standard simplex tableau. We will write it into the equation form and you can get it answer. It is, this problem is the solved example in your book. You can see it in detail and you can get the answer for that. Is that clear, Carolina?
Yes, it was just in the video, it was instead of negative 700, it was positive, and instead of negative 900, it was positive, but 500 was negative and 1000 was negative. So that was just, yeah. Okay, I got it.
Let me see. We have this example in the book. It is solved example in your book. Let me open it. Can you see the book?
Yes.
Yes.
See the technology. Thanks to the technology. Huh? No? Vishal, what are you talking? You are backbiting.
Huh? Sorry. Oh, I forgot my microphone was on. Sorry.
No, I'm just kidding.
I was,
It's okay.
I was talking to my dad about math.
Hmm. Here it is. You can see now, Carolina.
Yes.
You see, P equals to minus 700, minus 900, plus 500, and plus 1000. Now we will move this 700 to the other side. It will become 700 y1 plus 900 y2 plus minus 500 y3 minus 1000 y4 plus p equals to 0.
Oh, I see.
Like here.
Yes.
So when you
Yes, makes
write
sense.
them, it will become plus 700 plus 900 minus 500 minus 1000. Maybe I did mistake in the video, but this is
No,
the
you didn't.
okay.
It's correct. No.
Okay. Now we will see
Thank
the
you.
most negative number in the bottom row. Minus 1000 is the most negative. So this is our pivot column. Now we will decide the pivot row. 5 divided by 1 is 5. 8 divided by 1 is 8. So 5 is the smallest quotient. Here we have 0. We cannot divide 6 by 0. So we will leave it. So this second row is our pivot row and 1 becomes our pivot column. Also pivot element. With the help of this one, we make zeros above and below. There is only one number in the fourth and fifth row which we need to convert. So here when you apply the operations, you will get above and below equals to 0. Now again you will see in the bottom row which one is the most negative. Minus 500 is most negative. So this third column is our pivot column and third row will become pivot row. So with the help of this one we will make above and below 0. After doing this, again we will see in the bottom row, is there any negative number? Yes, minus 300 is the negative number, the only one. So the first column is our pivot column. And is there any positive element above dashed line? Yes, there is. One is the positive. So this is the only pivot row. With the help of this one, we will make above and below 0. So now we are here. We see, is there any negative number in the bottom row? No, there is no negative number in the bottom row. We will stop it and we read the solution. And in minimization problem, we directly read the solution from the top row. So x1 is 0, x2 is 700, x3 is 500, x4 is 300, and profit is 7,900, which is actually a cost, because we took the transpose. Is that clear?
Yes.
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 Any other question?
Yes, I sent you the questions from the exam that I'm confused about.
Did you send it in the WeChat?
In
Okay.
private, yes. It's question
Mhm.
about the Ghost Jordan elimination.
You see,
And
listen, what you did.
uh-huh.
I already gave you 3 points. In fact, I should not give 3 points as well. What is the major mistake? You did a very major mistake. Like if you have a problem like 3x plus y minus 2z equals to 2 and x minus 2y plus minus z equals to 3, 2x minus y minus 3y equals to 3. That was the problem. When we apply Gauss-Jordan method, we write everything in the matrix 3, 1, minus 2, and 2, 1, minus 2, minus 1 and 3. 2, minus 1, minus 3 and 3. What you did, you skipped this last column, this last column. You did not write it. You just wrote these 9 elements. You can see it. And I mentioned it here in the red that this is the right thing. This is what you need to write, and then you need to apply the row operations,
Oh, okay.
right? And
Okay.
similarly, in the second picture as well, you did the same mistake in every problem, and I still gave you 3 points.
So I skipped I didn't put in the between the brackets the numbers after the equal sign, right?
Exactly. Yeah.
Okay.
Any other question?
Mhm.
Um, for the classes, you said we were gonna have 2 classes. So is there gonna be a difference in what we do in each class, or will it be like maybe on Tuesdays we do the lesson and then on Saturday we do the exercises?
Well, like now there are, in fact, in our group, we have 33 people in total, right? But how many people are attending now?
5 now.
Yeah, you see, there are only 5 people. So it means that there are around 20 plus students, those who are not attending it. So in that is the reason why we divided it into the group, because maybe in America it is night, or maybe in some other countries the time is not suitable for them. So that is why we split it into 2 groups. We will discuss the same thing in both classes. You have to choose, you have to attend at least one. And if you are attending this one, you may not attend the second one as well. So if you want to attend, you are more than welcome. You can attend both classes, but one is mandatory, and we will discuss the same thing in both classes. Yeah.
Okay.
Any other?
Okay, great.
Okay. So
I have a question.
yes.
This is for the homework you gave today for lecture 7.
Mhm.
You said number 45 and 46, the applications. I didn't understand how to work with those.
Okay, okay. Uh, I solve them, and I make a video on Zoom call by solving them, and I will upload it later on. Okay.
Okay, thank you.
You are welcome. And in case if I do not upload it till tomorrow noon, you just give me a reminder, because I have so many questions, so many groups, and so many things to do. Most probably, if I forget, you just give me a reminder. Otherwise,
Okay,
I hope you don't need to give me reminder. But if in case if I forget, you just give me a reminder tomorrow till noon. Okay.
okay,
Mhm. Any other question?
thank you.
Welcome.
No,
When is
I'm
the final?
Mhm.
Sir, when is the final?
When do you want?
Sorry,
When do you want?
next year.
never.
Yes.
Yeah, no final. I already got the passing grade. That'd be nice.
Well, I think it would be last week of June, most probably. Yeah.
Okay, and will it be a mix of everything we've done for the year or just everything after the midterm?
No, not everything after the midterm. As I said, I excluded question number 4, part B from your exam, which means that now in the final, I will consider your whole chapter 6. You have to prepare whole chapter 6. So,
Okay.
in other words, your midterm carries 32%. Before it was 40%, but now it carries 32%, or so called 30%. Your 10% will move into the final, because almost 50% of round, uh, almost everybody did wrong question number 4, part A and B. So I thought maybe you did not understand it well. That is why nobody was able to solve it. So I just removed it.
No, we get that, but is there going to be material from chapters 1 through 6 on the final exam?
Chapter in the final exam, you will have chapter 6, you will have chapter 3, and if we have time, maybe we will study some other chapters, which is called sequences and series.
So it will have content that we studied before the midterm, yeah?
Yes, only chapter 6.
Okay. Okay.
Mhm.
How do we hand in all our assignments during the final exam?
Well, you can submit me anytime during the on the day of final exam or after the final exam or before the final exam. I will give you a date. I will give you a date,
Okay.
and then you can submit according to that date. Yeah.
How
Okay.
many more assignments do we have left?
Well, every lecture has one assignment. So in total, I mean, we will have maybe you will have at least 4 more assignments, at least.
Okay.
Yeah.
Mm-hmm.
All right.
So how about your workload?
Sorry.
I mean, how about your workload? How many subjects are you taking?
Quite a lot. I mean, there's Chinese, business management, ethics, logistics. I have like a project in logistics,
Mhm.
2 projects in ethics.
Okay.
Let's
So, okay, what is your experience about this live tutorial about mathematics?
I
Oh,
prefer
it's
this than what
great.
we.
This
Yeah,
is so good. Yes.
So
it's
good.
much
Please
better
keep
than
going. This is great.
Yeah.
Okay, that's good. That's good. Actually, before
But
in
will you still send them like record videos and then we just go through it in the lesson, or how will you?
come again?
Uh, you record like you did before, but now we only have like Zoom meetings too, right?
No, not only Zoom meetings. I will record my
Okay.
lectures
Yeah.
like I used to do before in the PPTs,
Yes.
and then I will solve example on the Zoom like I used to do.
Yeah.
Understand?
Yes.
Then we will have live tutorials. The live tutorial will be discussion on my PPTs, on my Zoom recordings, on your assignments. You will solve your assignments, you will discuss your problems related to assignment, and I will solve more assignments on the Zoom than before. Before I used to solve around 3 to 4 problems, but now I will try to solve more than 4 to 5 problems, maybe around 5,
Yeah.
6 or 10. And then we will make discussion on assignments, on PPTs, and on Zoom recordings. Understand?
Yeah. Yes. Perfect.
Yeah.
Another question: are the times open for negotiation?
What type of negotiation?
Maybe to change the classes so that more people can attend.
I don't know. You can talk to Mailing or maybe Christine because they are arranging the time, and they decided these 2 slots for fundamental mathematics. One is Tuesday and one is Saturday. You can choose either one. You can choose either one. As I said, we will have repeat telecast in both sessions.
Okay.
If you attend one, that is enough.
Okay.
Yeah. Okay, then
Okay.
see you
Thank
on
you.
welcome on Saturday, I think. Yeah.
Yeah.
I scheduled a meeting and I send you email. I send a link like before, and then see you on Saturday.
Okay. Take care.
Okay, bye bye.
Thank you.
Thank you.
Bye.
Bye bye.
Bye.